welcome to the Lead Bytes. Today this is second session of the load balances part 2. In this session we are going to discuss further about the load balances. To give you background, let's say you have an application that you have deployed in multiple countries, say in US, India and in Europe. For simplicity, let's say there is just single server in each country, and I have given sample IP addresses to each application server. Now let's consider one example that in India there is one user, and that is trying to connect to your application, say abc.com, right? So what happens when this user tries to access the abc.com? So I guess you are already aware of the concept DNS, domain name server. So what this domain name server does is it keeps a table list where it actually maps the abc.com, this abc.com or any website, to the IP address that it is hosted to. Now in this case we can see that this abc.com can have 3 entries, each regarding to each IP address. For simplicity, this is 1, 2 and 3, right? So whenever user is sending request to access abc.com, the request is first received by the DNS. Now this DNS it has 3 addresses, right, representing to abc.com, so where it should redirect to the user. So this DNS is you can say smart enough to know that this user is near to the IP address too. So this DNS sends back a response to the user that if you want to access abc.com, then please connect to the IP address 1.2.2.2. Then next request, this user connects to this application server and then continues talking to abc.com. Now what happens is that when the browser sends request to this 1.2.2.2, so the machine generally the client machine generally keeps a copy or just copy of information that if I want to talk to this abc.com, I need to connect to the IP address too. And then if the cookies are enabled on the client side, so this information is stored into the cookie at the client side. So every time, next time when it wants to talk to abc.com, the client does not send request to the domain name server, rather it can directly talk to this server, application server. Now second thing is that when it is stored in a cookie, the every cookie has a time associated with it. It is called as time to live, TTL. Okay, so whatever information is stored in that cookie, it will be relevant only for certain time. Let's say it is 5 minutes, for example. So for next 5 minutes, whenever this user wants to talk to abc.com, it will refer that I want to connect to this abc.com, which is at server 1.2.2.2, and then I'll send request to here. Once this time to live is over, this is like you can say a timer. So from 5 minutes it will go to 0 at some point, then this cookie is no more relevant. So after 5 minutes the client has to send again request to your domain name server. Now why is that? Because most of the time the IP addresses associated with the app server are dynamic, that are configured by the internet service providers, right? Until and unless they are specifically made static, when they do not change, that is different case, but generally they are dynamic. So Maybe tomorrow this IP address could be something different, like 1.4.4.4, right? Something like that. So in that case, this DNS will update this IP address to 1.2.2.2 to 1.4.4.4, something like that. So every time after the cookie expires, the client will again send a request to the DNS, get the new IP available if any, and then it will send request to that IP. Now suppose this app server that is running here in India, let's say it goes down for some reason, right? So now what happens is that this user has cookie saying that abc.com is sitting at 1.2.2.2, and it tries to connect to it but it is not available. So it will just keep reloading, and nothing will happen on client side and client will get frustrated, right? So, and another thing is that as the cookie is still there, it is not expired, so the user will not send request to the DNS till 5 minutes are over. So right, so at least for the 5 minutes, or at least for the time to live is not expired, this user will experience the downtime of the application, of your application. After 5 minutes are over, again this user will send request to your DNS. If DNS is smart enough, then it will know that this server is no more active. How that DNS will know that? It is something called as heartbeat check. Okay, so this DNS is much more smarter. Okay, so whenever there are the load balancer in the market, those are built on the top of the DNS. Okay, so DNS is smart enough to do the name resolution, as well as it is smart enough to do the heartbeat check. Periodically it keeps checking the health of each application server, whether it is up or down, and then it will automatically reflect in its table that if this is not available, then this user should connect to this Europe server rather, instead of US, because US will give more latency. So this logic is built up on top of the DNS. Okay, so nowadays the load balancer in the market are built up on the top of the DNS. So they do multiple functionalities. They do the name resolution, they do the heartbeat check on the servers, and they will do the load balancing also. All right, so in this case, how uh, we can use the load balancers to solve this problem, that what we want, that instead of the expiration of the cookie, when user will be stuck for the 5 minutes, and then it will know that the location of this abc.com should be now used to this IP address, and then go there. Is there any way to solve this problem? That we will see in the upcoming lecture. Thank you. If you like the video, please like, share, comment, and subscribe the channel. Thank you.